Good afternoon, everyone.
Okay. Hanggang 4 pala? 4? Ay, alang-alang ako. Hindi ako mga...
Hello, Maxi Metal Team. Hi, Miss Bong. Uy, Sir Randy is also present. Friendship Pawi.
Yes, ma'am.
Hi, Sir
Alam mo
Randy.
naman yan si Sir Randy, very
Yeah.
supportive.
Hi, Sir Randy. Yes, and our friends from Kyowe.
Yes, ma'am. From QA, from Intercon,
Yes, Shimano is also present.
on semis also present. Hi, Sir Nino.
Hi, Sir.
And also from Yamaha. Hi, Sir Don.
Good afternoon, Maxi Metal Team. Ayan, nakaon ang kanilang video. Andyan si Miss Bong. Mag-video nga ako. Hi,
Ayan, ma'am.
ma'am.
Si Dennis na yan.
Yes po.
Yan na sila.
Apo, thank you, ma'am.
Kamu? Wala ka nakikita. Ganyan. Yan, sa gitna. Yan. It's all.
Permanent bites. Permanent bites. And so step back.
Magpunta ka project.
Pwede na yan.
Kita naman eh. Okay, sounds.
Yeah, palaki yan.
Miss Dayan.
Yes, ma'am.
Ma'am, hindi si Michael ang a-attend dun sa machine shop po namin.
Noted, ma'am. Thank you po.
Progressive.
Oh. Sorry yan. Tingnan niyo po ano kung sa inyo rin to.
Hindi, pinabasa na namin to.
Ha?
Basa na.
Ito yan.
Ito ng kami. Ano, hindi lang.
Hi everyone. Are you Hello guys. Are you guys rinig niyo po ba ako?
Rinig po.
Ayan. So let me screen share. Ayun lang, nawala yung screen share ko. Wait lang.
Wow, ang daming attendees ng VPMI. Valerie, is this Valerie po?
Yes.
Hello, Valerie. Ano, wait.
Hello!
Hello.
Magandang
Ang
hapon
daming
po.
attendees.
Opo,
Good
opo.
afternoon.
Good
Afternoon po.
afternoon. So, sir, naka-ano ba kami? Naka-big screen kami dyan sa conference niyo.
Yes, ma'am.
Hala, di kitang-kita pala yung aming mga flaws sa muka kasi ang laki. Charot. Thank you for joining, sir.
Ayan, wait lang. Ayan, kita. Ayan. So, let us begin with the webinar official. So, hello everyone. Good afternoon. I am Anna
And I'm Pawi.
of CADCentric Solutions and will be your host for today's webinar about STAMPACK together with Logo Press. So first, we'd like to acknowledge and thank all our participants for taking time to join us today. We hope everyone is doing well and staying safe and syempre nakapag-lunch na rin. For this session, we have a special guest speaker who will be sharing valuable insights and will be doing a short live demo. So we'll be introducing him shortly. We're also joined by our CAD-centric technical team leader who will help connect today's discussion to real-world applications, particularly within the Philippine manufacturing setting. But before we begin, let me quickly walk you through our webinar protocols. So first, please introduce yourself in the chat box. Type in your name and what company you are from. For better listening experience, keep your microphones on mute, please. If you have any questions during the discussion, you can message us in the chat box so we can record your questions and we will answer everything by the end of the discussion of each topic. Keep your commentary positive and optimistic in the chat box, and this webinar will be recorded for our documentation purposes. So, next slide, sorry.
Yes. So if you want to get to know more about the updates of CADCentric Solutions, appearing on your screen are the QR codes of our social media accounts. So please like and share our Facebook, LinkedIn, Instagram, YouTube, and we also have community pages. You can also visit our website. So scan the QR code using your phone cameras, and we will also share the links in the chat box. Then you will be redirected to our social media platforms.
So there, a little introduction of our company profile. We are CADCentric Solutions, authorized reseller of SolidWorks, SolidCAM since 2012. We've been providing software solutions for about 30 years to 10 different industries, including automotive, electronics, semicon, molding, and many more. We have more than 400 plus customers, and now we are shifting to advanced innovation like AI, automation, etc. We are acquiring new software solutions to also widen our support to other industries. As a tier 1 supplier, we excel in customer demos, trainings, and support, achieving the highest new customer acquisition in AP South region in 2025. Beyond webinars, we also organize successful industries, events, and technology days where customers can explore new technologies and interact with other trusted suppliers and partners. Our achievements last year include awards for 100% Achievement Award, Top Sales Performer in CAA region, which was awarded to Miss Luz Basan, and Top Elite Engineer in CAA region, which was awarded to Mr. Claude Santos.
Yes, so with those milestones in place, let's now take a closer look at the solutions that make it all possible. Here's a quick overview of our solution offering as shown on the screen. So first, we have our modeling solutions. So basically, we serve 3D mechanical software, which is our flagship brand, SOLIDWORKS. So we also have DraftSite, a powerful 2D and 3D drafting tool. So we do recommend it to the AEC industries. Next is sheet metal mold and die solutions. A creation of plastic and mold designs now become faster and more accurately by automating common tasks like mold layout under iMold. And logo press, which was also be discussed later on by Sir Sunny. It also automates strip layout and progressive die design. Third is the simulation and testing. So this one is an advanced solution which runs on top of our SolidWorks, where it virtually tests new products. So it will lessen the use of your prototypes, rejections, and delays, as well as reworks. Next is machining solutions. So we have a CAD-CAM software for CNC milling, lathe, Swiss, type of machines. So these are certain modules where it brings less wear and tear on your CNC machines, also reduce machine maintenance cost, and it extends its tool life. Next, we also have our factory flow analysis. So this one is perfect for the production engineers who can simulate, analyze, and improve their production flow in a 3D virtual manufacturing environment before the execution. Next is data project management. Users will have the ability to create programs, monitor various projects, where they can easily meet the timelines and deliverables in real time using our 3D experience platform. CADCentric Solutions also offers QA solutions. So this is quality data analysis solution used in statistical process control. And lastly, we have cloud services AI for design. So now SolidWorks AI has a redefining design intelligence. It accelerates engineering workflows with AI-powered design assistance, automation, and real-time insights built directly in your CAD environment. So, all right, let's now move on to the main highlight of today's webinar. So, Anna has a quick question for everyone.
So may quick question lang naman ako sa inyo. So how many of you are still relying on trial and error when it comes to forming or tooling? Pwede kayo mag-raise ng hand or wag na mag-heart kasi alam kong ano yun eh, medyo may heart or ano. Pwede kayo mag-raise ng hand, ganun. What? So I know maybe it's a common approach and it works, but it also comes with challenges like, rework, delays, and material waste. So if we look at the manufacturing landscape here in the Philippines, industries like automotive, electronics, and metal fabrication continue to grow, and many of our companies are part of global supply chains. That also means higher expectations. So faster delivery, better quality, and lower cost. So the challenge is a lot of validation is still done physically. Syempre, you design, tapos you test, adjust, and i-repeat mo siya. While that process works, it's not always efficient, especially when multiple tryouts are involved. So the question is, how do we reduce trial and error and catch problems earlier? So dito na mapupunta yung ating ano, char. This is where we're seeing a shift toward a more simulation-driven approach. So, yan. So, validating process during the design stage instead of during production. And that's why what we'll be discussing today, how tools like Logo Press for design and STAMPACK for simulation can help you move toward a more efficient and predictable workflow. So with that, let's start our technical discussion. Now, to guide us through the technical discussion, he has extensive experience in manufacturing industry and has worked closely with companies to improve their processes and efficiency. Today, he will discuss the common challenges in the industry, such as trial and error, delays, scrap, followed by a brief introduction to Logo Press. He will also share how these solutions can be applied in the Philippine market, along with their benefits on global scale later on. So with that, I'll hand it over to our technical team leader, Sir Sonny Rivera. Sir Sonny?
Yeah. Thank you, Miss Ana. Ang ganda naman ng um, introduction. Yeah. Okay. So, share my screen. Okay. So, yeah, CSI will present you Logo Press and STAMPACK. So, Logo Press is actually, it can automate your tool and die designs. No? Usually, gumagawa tayo ng mga progressive dies. No? Medyo challenging ang pag-create ng progressive die. So that's why to help everyone to those challenges, we at the CADCentric team naisip namin na maghanap ng software that may help the Philippine industry to be more productive and also competitive sa ibang mga countries, no, because nowadays based on my experience dun sa mga industry, no, sa pagdating sa pabilisan ng paggawa ng mga molde, no, medyo nakakaungos na si China sa atin, although in my experience also medyo mas maganda pa rin ang quality ng Philippines, no, versus dun sa China, pero hindi ko naman siya nilalahat, no. Marami din talagang magagaling na gumawa sa China na die designs, no, and they deliver faster talaga actually. So with that, no, kailangan nating sumabay as Philippine teams, no, sa market natin sa Philippines. So parang medyo awkward naman kung tayo na yung parang tier 2 supplier ng mga automotives, and then pagdating sa creation ng die and mold, no, pupunta pa ulit tayo ng China to import yung mga dies natin, because alam naman natin, no, pag-maintain ng machine shop and also ang tool and die is very hard, no, because of the na mentions na mga challenges natin ni Ana kanina, no, yung kagaya ng mga reworks, no, yung paminsan hindi natin makuha ng mabilis yung output na kailangan natin, no, pag usually nakakailang trials tayo bago natin ma-attain yung or ma-achieve yung ating targets, no. So those challenges, no, yun yung isa sa mga bagay kung bakit medyo nadidelay yung ating mga production, or minsan, no, mas pinipili ng ating mga managers or ng ating mga heads, no, yung CEOs, no, to actually import na lang yung mga ganong klase ng mga complex na molds natin, like ito nga yung ating progressive dies, no. And not only that, minsan yung mga single dies, lalo yung mga deep draw. So usually inaan na rin natin siya, ini-import na rin natin siya, kaya medyo marami na ako nakakausap na mga Philippines company dito sa Philippines, no. Usually parang lagi nila sinasabi, sir, nag-review lang po kami ng ano natin, ang mga drawings namin, usually nag-repair na lang po kami. Most of the dies came from Japan, no? And sometimes we import that from Singapore, Thailand, something like that. So, kaya ito yung naisip namin to help us, no, to build more faster para makasabay tayo doon sa manufacturing speed ng mga ibang bansa, no. We have logo press and STAMPACK to help you develop your die faster. Okay. So I will just give overview about logo press, no? But the main presentation for today is STAMPACK actually. So our friends, no, from STAMPACK will show some demo, no, para makapag-help sa atin to simulate your mga parts natin. Okay. So after that, concepts and then yung yun nga yung demo natin. Okay, so umpisahan ko na yung sa logo press, no? Actually, ano nga ba yung logo press, no? What is logo press? Okay. Logo press is an add-in software from your SolidWorks, no? To help you develop your tool and die process, no? To make it faster and smarter doing the design, no? Because yung mga challenges nga natin usually is nandun sa pag-develop ng ating mga molds. And also, logo press can help you design your strip layout more effective, no, and more efficient, no, because logo press can not only to automate yung pag-create ng ating strip layout, but to optimize it using yung magandang nestings, no. May mga nestings din tayong ginagawa with logo press. Yan. Okay. So, sorry. Yan. So usually, no, ginagamit natin yung ating SolidWorks to design our product, no, or sometimes ginagamit lang natin yun to actually review yung product from our customers, no. So after ma-review natin yung product, no, na binigay sa atin ng customer o yung ginawa natin, no, ang next step nun is actually we develop na yung tool and die process natin. So kung for example, like the parts that is presented here in the screen, kita nyo medyo complex na siya. No? So minsan much better kung gagawin natin siyang progressive, no? So logo press can help you do the parametric part preparations, no? From the first bend, second bend, up to the third bend. So nagagawa po siya ni logo press to automate, and also removing of the piercing holes, no? Pilot holes as well. Sometimes we also remove the forming, and then we can start the platting process, no? So this process that you do is actually the automation or the creation of the strip layout, no? So after mo kasi mag-platting, so pwede mo kasing i-analyze yung parts, no? So pakita natin kung nasan yung stress, no, at saka yung mga bending errors natin, or nagkakaroon tayo ng thinning tsaka thickening, no? So this is now showing you in the screen is the strip layout, no? So ino-optimize natin kung ano ba yung best way, no, to use a strip, no? You can add actually a stages, no, pagkakulang yung stages ng ating progressives, no? And then next thing to do is to actually build na yung mga punch and die natin, and to add yung ating tool structures, no? Logo press is very good in having a library ng mga tool structures natin, no? Even yung mga standard components, meron tayo dyan. Si logo press na naka-prepared, no? Para at least drag and drop na lang, no? Choose na lang tayo dun sa library natin, and then automatic mag-insert na siya dun sa ating tool and die components, no? So logo press, no, meron siyang at least 100 plus components, no? Tapos supported siya na at least mga 50 different manufacturers ng mga die and components, no? Die design components, and also yung mga plates natin na meron tayo. So usually kasi 'di ba parang in order na lang natin tong mga plates na to para mas mabilis sa production natin, kaysa bibili pa tayo ng mga raw materials, no, to machine it, no, flattening, no, squaring pa natin. Usually binibili na natin siya as blank. And nowadays, no, nung nasa ano pa ako tool and die business na manufacturing company na isa akong leader din doon, actually. So binibili namin siya from Japan, yung uh, mga tool structures natin. Tapos from there, dinidesign na lang namin yung mga punch and die. So yun na lang yung kinecreate namin para mas mabilis yung production. Kasi we are targeting at least 4 to 7 dies per week. Parang ganyan. So, kagaya nito ni Logo Press, no, meron siyang mga library dito na pwede mo siyang ilagay, no, or i-utilize, no, para mas mapabilis yung process, no. Ayun yung kagandahan ng meron tayong Logo Press in our tool shops, no. So, yung die development, design development natin, strip layout, and also yung mga punch and die, no, makikita natin siya. And then, as you see in the video, nakita natin na nagkaroon tayo ng dynamic interference, no, para makita natin how the tool and die will behave. No? So, nakita natin siya, no, mas madali nating malalaman kung working well ba yung ating die. Okay, so to summarize yung mga napakita ko sa kanyo kanina, so Logo Press can do yung blank development so na mas mabilis as mas optimize. Actually, meron pang feature si Logo Press, no, to optimize yung cutting lines natin. And also, Logo Press is good in doing or automating the strip layout and the tool structures as well, no? And then die simulation, yung basic natin, no, na simulations. So other than that, we have more challenges, no, during our die design, no. Meron pa tayong mga springbacks and dimensions accuracies na problems, no. So hindi naman lahat ng material, no, usually nagbibehave ng minsan kina-calculate natin, no, na iniisip natin dapat pag bend ko 90 degrees automatic 90 na siya, no. But we have springback, no. Depende sa materials kung stainless ba siya or plain carbon steel, no. So minsan nag-iiba-iba yung springbacks, no, kaya nag-a-adjust tayo. Dimensional accuracy, no, ito yung pinakamalaking challenges talaga, no. Because at the start ng process we always use parang tinatansya lang natin yung ating blank size, no. And then later on, pagka nasukatan natin after the process, the whole process happen, tsaka pa lang natin masusukat yung actual parts, no, na tinry out natin. And then tsaka pa lang tayo mag-a-adjust dun sa blank size, no. So what we do, we always laser cutting, no, para dun sa mga blank size or tawag dito, wire cut, no? Something like that, no. The other problems or the other challenges is the trim lines, no, yung blank development niya, and also yung tinning and cracking, no. Usually madadaanan natin to upon dun sa process na ng tryout, no. Pagka nag first tryout na tayo, so meron tayong mga forming, no. So dun pa lang natin makikita yung tinning and cracking, no, which is very crucial, no, because after the tryouts, no, yung first tryout natin, tapos masusukat na natin yung tinning, tapos nakita na natin kung may cracking. Of course, nag-manufacture na tayo ng ating mold, no? Gumawa na tayo ng ating tool and die. Kaya siya na tryout na natin. Then tsaka pa lang natin malalaman na hindi pala masyadong maganda yung tool structure natin. So kailangan natin mag-adjust. We have to remove all the parts again from the die, no, disassemble and then bring it back to machine shop to adjust, no. So kaya medyo challenges talaga yung gantong klase ng development, no. Surface defects as well, no, yung wrinkling, no, and also yung multi-step method, no, yung planning, no. Minsan meron tayong mga stages, no, tapos naisip natin parang baliktad pala dapat, mas nauna pala dapat yung forming bago yung piercing, no, para mas accurate yung diameter or yung position ng holes natin, no. And then lastly, of course, yung ito talaga yung pinaka natin, yung time and cost reduction using the tryout. Kasi nga habang dumadami yung tryout, no, kaya dati meron kaming may target kami dun sa namin na at least 3 tryouts lang, dapat mag-good na yung ating model. Pero napakahirap talaga nun, especially if you're doing progressive die designs. Okay, so with that, no, yung mga challenges na yan, so pwede natin siyang ma-solve during the simulation. No? Kaya ano nga ba yung STAMPACK? No? Ano ba yung makakatulong sa atin para gawin yun? No? So STAMPACK is advanced forming simulation that physics-based solver na pwede makatulong sa atin to analyze yung ating die, no? Or yung ating development, no, bago pa tayo mag-proceed dun sa manufacturing para malesen natin yung reworks. Okay? So, here, no, stamp will be presented by our friend from STAMPACK, Sebastian. Okay, so Ana.
Ayun. Hello. There.
Ayan.
Sir Sunny. And now for the next part of our session, it is our pleasure to introduce our special guest speaker joining us. He is the application engineer for STAMPACK and has extensive experience in sheet metal forming and simulation technologies. Today he will be discussing the next key sections of our agenda, from common forming issues and introduction of simulation-driven workflows to the live demonstration of STAMPACK, including its business value, real-world application, and benefits for manufacturers both in the Philippines and globally. We are very honored to have him with us today to share his expertise and industry experience. So without further ado, please join me in welcoming Sebastian Dance. Welcome, Sebastian.
Hello, good afternoon from my
Good
side, or good
afternoon.
morning from the European side. So, yeah, thanks
Good
a lot.
morning. Good morning, Sebastian.
Good morning to you.
Yes, thanks a lot. So I will try to share my screen. Maybe you can invite me to
Oh,
share
yeah.
it because it's blocked actually.
Oh, wait. Joshua.
So what time is it
Yeah,
in,
you can
in
share
your
now.
Yeah, Joshua.
We have
geo?
8 o'clock in the morning actually here in Germany.
Oh, good morning.
So now it's working, I think. Just 1 second. Did you see my screen now?
I already made you the co-host. Can you check if you can share your screen?
Yes, I will do. So, number 2. Now it's working?
Yes, it's working.
Yeah, fine. Okay. Okay, perfect. Perfect. So once again, thanks a lot that we have the possibility to share to you our information coming towards related simulation software STAMPACK Express. Yeah, first of all, I will introduce our company from our side. I will introduce my side for the first, and then we will directly go into the deep detailed discussion towards our software, towards the benefits out of software, and especially towards the benefits in the combination of the softwares we have. So the logo press on the one side, the STAMPACK on the other side. And I think you definitely will refine yourself, your daily processes in the presentation to think about, okay, where are we located actually, where we could be located with interpreting more into it towards the digitalization possibilities, especially with the CAD system, especially with the simulation past, to more or less combine your actual structure to get more benefits out your processes, and of course then lately cost saving and time saving. But I will come back to this topic later indeed. So first, towards our company, we are the STAMPACK GmbH. The STAMPACK GmbH is founded in 2018. Yeah, the STAMPACK or the simulation solver, its integration is quite much older than our company itself. So the first commercial version of STAMPACK was on the market in the 1995 years. So the structure of the solver was completely innovated and developed on the University of Barcelona in Spain. Yeah, and software is growing at least over the 20 years until 2018 in different kind of market segments. But let me say, coming from the university side is some kind of scientific software, not directly specified for the industrial market itself. And this was the possibility where the STAMPACK GmbH was founded. And we have the possibility to acquire the complete team from the former STAMPACK version to bring the software to the next level, to an industrial standard sized level, where we more or less feel the pain and gain of our customers and implement it into a software for a better and competent and smarter usage of the software itself. So 2022, the release of STAMP Express was fully made. And we are working 5 years where the big Autoform group knocks on our doors and asks us, okay, what is the possibilities we have to get a better combination in the whole portfolio? Because if you're a little bit familiar with simulation software, the Autoform group is more or less the big player on the market towards simulation software, and they acquires the STAMPACK GmbH to update their complete portfolio. So we are not competitors itself. We are not competing to each other. We are going parallel towards the market to this different segment. I will talk about that later a little bit to understand it better and to have a huge portfolio on simulation possibilities for our customers. Actually, we have an international team. As mentioned before, the development team is formally also sitting in Spain in the nice sun of Barcelona, let me say it like that, yeah. We are sitting here in Germany, so the sales, technological decisions, the marketing, and also the support team is located here in Germany. And we have a second office, it's transferred to the Czech Republic, where we have the support and for the all sales also the quality assurance testing, the beta versions coming up. It's done by those teams. What's the idea of our software? The idea of our software is quite easy to understand. We coming also from most of you, we are coming from the tool design itself. So also I worked as a tool designer. I started learning tool design in CAD systems. And secondly, I learned to do simulations of my tool design. And we had the problems that all of the softwares were on the market has some kind of scientific approach. We have to be very familiar with material characteristics, with doing FEM technologies, meshing the parts, yeah, doing correct measure structures of the parts. And it's quite hard to know that it's a big knowledge you do have to start with quite reliable and effective simulation. And we have a completely different approach. We say, no, the idea must be that more or less at least every tool designer have the possibility to check his own processes by himself. That's the general idea. But of course, not everybody can be a scientific in FEM. Not everybody can be a scientific in material characteristics. But we have the idea to implement the software to lower the knowledge level for the entry of the simulation software. Yeah, that means that more or at least everybody can use it by himself, but not have any deep knowledge in this topic. Of course, it's also an FEM simulation software. It's also a software that's dealing with material characteristics itself. But we take our knowledge, put it into the software, and give it to the customers to work with it. That's the idea. So from this case, we can say the simulation of STAMP Express is made from tool designers for tool designers. That's more or less the look and feel of the software. Of course, that means we have to use a different approach. That means it uses the language of the tool designers at one side. It has to provide fast computation and reliable results on the other side, because we want to do it for the tool designers. They use it in the daily business. They can't wait several days to get results, of course, to be efficient on that case. And of course, it must be affordable on the other hand. When you have a closer look to the marketplaces we can do, or we can rely towards the simulation software, we have different segments. And I think everybody from your side will find yourself in one of those areas in actually what you produce. So we have a big market in the electrical parts, a big market actually in the cup geometries and all the round shaped symmetrical parts. Yeah, classical bending and progressive dies, of course, are fully made with our software. And of course, also the automotive area, structural components, thicker materials, for examples, in the automotive area. And one specific area are the so-called heat shields area. To come to the first section, it's quite important to understand what are our pains. Of course, you're absolutely low what is the pain you have, but what are the physics of failure in general? What can you see? What are typical issues you have in your daily business? On one side, of course, any cracks, failures in material, any things that happens in you're out of the tryouts fast, yeah, where you see your tool first time on the press and something happens. This could be a crack. It could be also additionally some thinning issues, yeah, not only a crack itself, also the quality. You have a bad thinning condition on the part. It's not in tolerance for the customers. You have to check and think about and rethink your process maybe. On the other hand, when we have thinning issues, we could also have thickening issues. Yeah, the other way around. Yeah, to have some burrs on the part, some overlapping of the material, something like that. Classical surface defects, when we want to have class A parts on the surface skin, yeah, to detect and to see, okay, what happenings, especially when you see that in the physical tryout, we have a big problem. We have to go back the huge step back forward and have to look and see where are the issues, where they are coming from, and in the next step, what can we do? Yeah. Unfolding errors coming from the CAD system. The CAD system have a perfect mathematical structure to doing the unfolding tests, but relied on the tool, on the real process later on. There can be differences, of course. To detect them in the early stage, to directly intervene in the CAD system. Force prediction. Are we able to press this part in our manufacture? Yeah. Is our tool press, has it enough power to do that, for example? And of course, springback and tolerance issues in general, more or less. And I think many more things, yeah, but just to have a quick overview, what are the specific cases? So when we can combine it to a specific area, I have selected 4 examples just to understand what we can do with simulation for these more or less also quite easy examples. Yeah, when we have some kind of blade like that, yeah, detection of cracks and correction of cracks are one of the parts you have to do. There's some typical areas in some kind of parts where you have problems. And another one is some kind of crimp connector part. Yeah, what are my correct bending angles to get the correct springback? What are the correct bending angles to set up one stage after another to more or less close the material completely and in a good way? Or the springback compensation. Yeah, when we have springback issues, we have anything that happens in this area, maybe to have a closer look, we can also go inside this one to have and feel in a little example for that. Yeah, what is the challenge? More or less, of course, each step will be simulated in the software. Each single step with the tool design you want to try. Yeah, and you see in every stage what's happened with the part. You see the bending operations, you see the coining operations, you see the forces needed, you see the forces needed for the holding down of the part. And of course, then you will get any result later on. Then you can compare it to your optimal design and then see, okay, my safety zone, so my feasibility itself is quite good. But when we check the tolerance towards the target we want to have, we find some, for example, strong differences. Yeah, what can we do? What are the idea? You see here, we have a big differences. By far, it's no problem to have that because everybody knows in the most cases what to do. We have to overbend. We have to rethink the design. But the problem is we know it when the part is already manufactured. And that's the big problem we have. So we have to transfer this approach into an earlier stage of your design phase. That's the big approach towards simulation. And to clarify that much more, oh, I'm sorry, I'm off of this presentation. Just 1 second. what is the idea from trial to and error to the virtual centenary? Yeah. When we have a classical view onto the classical process chain we have, you directly see, okay, we get a product from a customer or your own product. We have to think in some kind of creative way how to deal the strip design, how to unbend, what is the correct operations, yeah, one step after another. Then we have to do a tool design, a tool assembly, maybe in between also an checkup tool, yeah, to see, okay, if any different areas are specific for us, and we go to our physical tryout. From the theory, it says that more or less 70% of the tool costs are included in the area from the product until the tool assembly. Yeah? And 30% of the costs are included in the physical tryout itself. Doing the tryouts, doing the loops you have to do, quite normal. And of course, when we have found out that we have some problems in the first tryout of the tool, in the worst way, we have to go back the whole way back around to the method and rethink our method plan in general. And this can have a big impact to the costing, to the time, and of course, all to the related employees you use for that. Because when you have to recheck a physical tryout, who's included? There are the guys from the tool shop floor included. There are the guys from the design development area are fully included. Some team leaders are included. So a huge impact to the personal area is also included in this process. And this is more or less the big part we have, not only the material part, also the physical part that we need in that case. And the idea is to say, okay, when we say the latest we check, or we have any error in the tool, for example, in the process, the later the error detection is, the higher are the costs. That's more or less theory. Yeah. What we want to provide is that we have not these problems itself. Yeah. So when we have here the product chain as well, we integrate the simulation in between the method planning, strip layout design, and the tool design. So we add in more or less some kind of virtual tryout inside the process in the early stage. More or less, we do integrate a virtual press inside the process chain. Yeah, that leads that we can do these iterations in a very early stage. And when you rethink about the costing, it's a very early stage. Yeah, and only one person, maybe two, to discuss are integrated in this process. And that's the big difference between the physical tryout. For the first, of course, we have to design the process itself. So we have to do unbend as shown before. We have to rethink the method planning. And for that use case, we use simply the local press area. So for that case, I have a short video for you to have a feeling, fully commented. I hope it works with the sound. We have to check. Yeah. And if you hear if you don't hear the sound, then please raise your hands. We will check that. So let's test. I think I have to. So the video is now. You hear something actually?
No, Sebastian, we
We
cannot
will.
hear anything.
Let's check. I think it's something of the settings of the Zoom tower.
When you share, there's in your right side, there is a button there. You have to press share with sound.
On the right side, you see?
Yep.
There is it. Once again,
LogoPress die design software is a leading SolidWorks integrated solution
it's working.
developed specifically for the tool and die and metal stamping industry.
Yep.
With over 30 years of experience in die design, LogoPress has become a trusted worldwide leader, recognized for its powerful automation, intuitive workflow, and deep engineering capabilities. Designed for efficiency and accuracy, LogoPress enables designers to quickly predict their blank and evaluate formability risks, easily generate reliable strip layouts that can also be automatically updated for engineering changes, then model the tool faster thanks to hundreds of dedicated commands and features, including die debugger. Design changes are automatically done thanks to built-in parametric modeling. This significantly reduces rework, streamlines quoting, and overall shortens design cycles. LogoPress also integrates seamlessly into modern tool design workflows. When paired with forming technologies like STAMPACK, users gain a complete design and validation loop, allowing issues such as springback, thinning, splitting, and wrinkling to be detected before production. Let's start with Flatten. LogoPress Flatten is a fast, intuitive, and highly accurate solution for generating flat patterns from even the most complex 3D formed parts. It enables designers, estimators, and tool makers to work directly within their familiar environment while processing both native and imported geometries with ease. The software excels at handling double curved geometry and complex 3D shape. This makes it valuable for tool and die operations in industries like automotive, connectors, aerospace, packaging, and medical. Its support for full and partial unbending and automatic K-factor calculation ensures exceptional accuracy across a wide variety of materials and part conditions.
Actually, there's no further comment inside the video. So what you see now is the classical approach to the unbending software. It's very nice and done from the software side. And what's also very nice from my side, because I seen LogoPress 2 years ago for the first time, is also the visualization itself in the software. Yeah, to get a feeling what's happening, to get the idea what's happening in a very common way, to get a first impression also to thinning areas, for example. Yeah, parallel to the classical simulation approach, and that's more or less the right common situation in that case.
By enabling rapid flattening and early verification of forming behavior, LogoPress Flatten streamlines quoting, reduces uncertainty, and enhances communication between engineers and manufacturing teams, ultimately accelerating development cycles and improving part quality. LogoPress strip layout is the next step in the stamping workflow, transforming the theoretical blank generated in LogoPress Flatten into a complete manufacturable strip. While Flatten provides accurate FEA-based blank prediction for complex 3D parts, strip layout expands this foundation into a full process-ready layout used for die development, feasibility checks, and quoting. With strip layout, toolmakers gain powerful capabilities such as rapid strip creation, material optimization, and reliable pitch calculation. The system also delivers cutting force and tonnage estimation, punch information, and other requirements needed to validate a concept and produce accurate quotes within minutes.
So the next step that I will show now is to integrate each areas of the layout towards the strip design, so the customer can decide which kind of bending situation we want to have. You don't have to implement all areas. Yes, you can directly configure, okay, which kind of area we want to have, which kind of stage we want to have, and where, in which station we want to have that. And the system automatically regenerates the strip design for you. You can implement idle stations if needed and continue, of course, with the full strip design. It will be fully development. That's what's going to happen now in a very accurate way to have the full predefined strip design for the first stage. Then of course you can do then several adjustments for the first approach, doing the feeding, doing the in between waste area, so to check, okay, do I have a process add material for the strip connection, for example, so you can play around with the parameters. Let me say it like that, to define the strip design as you want to have it in that area. So what the video is now showing is to set up the first cutting punch. So it will be fully automatically detecting, okay, what is the pre-shape area of the part. You will directly generate the cutting punch for those area. In that case, the quick and dirty approach. We have doing the sketch with the area of the punch, and then he selected the correct way, directly transferred throughout the complete strip design. It will be fully updated automatically when you do the first approach towards this, and then going to the next step of the code. So doing here now, adding the punch mismatch in different shape areas, out defining what you want. Every approach is possible in that case. And then finally have a closer look to set up, for example, also the bending punch. That's what the guy's shown here, to how to generate the form steels, for example. Very quick and easy. The system directly see, okay, we have some surfaces integrated in the part, and then we'll regenerate the system here. And another approach that we have in the system is the fully automatic generating of an strip design and also an unfolding design by using simple mathematic formulas to directly set up a so-called unfolding of a round drawn part. So it's fully done automatically. You can also directly implement fully automatically the strip connections towards this, depending on what kind of you want to have.
By turning an accurate theoretical blank into a well-structured strip, LogoPress strip layout helps teams standardize processes, reduce engineering time, and accelerate tool planning, from concept to press-ready validation. Into our last subject, LogoPress die design. This is the biggest part of the LogoPress family. LogoPress die design is a comprehensive, production-focused solution built to streamline the creation of dies used for forming, cutting, embossing, and shaping sheet metal parts. Designed specifically for tooling engineers and manufacturers, it provides an intuitive environment for building accurate, manufacturable die designs directly inside SOLIDWORKS. A standout feature of the LogoPress die design package is the LogoPress Die Debugger, a powerful virtual simulation tool that allows you to visually test and validate how a die functions before any steel is cut. With Die Debugger, designers can animate the die's motion, detect interferences, check timing, and ensure components are behaving exactly as intended throughout the stamping process. This significantly reduces trial and error, shortens debug cycles, and helps catch costly issues early in the design phase. Beyond this simulation, LogoPress Die Design offers an extensive library of die components, automated functions for building die sets, tools for working with strip layouts, and intelligent features that reduce repetitive tasks. Combined, these great capabilities allow engineers to design more efficiently, improve tool accuracy, and deliver reliable results with greater confidence. Whether you're developing single dies or highly complex progressive systems, LogoPress Die Design provides a complete workflow from concept to production.
So one last time, let's dive into the software. What we are showing now is the more or less predefined tool design, where we have integrated the base of the tool, also the top areas of the tool, directly going to the next step to implement the strip layout, to change the spacing, to define more or less the presets of this area, of course, for the guiding of the strip design in that area, for example. So also here, several additions possible, several adjustments directly possible, doing in the menu, not doing directly in the SolidWorks design, so completely menued by the system itself to change these areas step by step in that case. Of course, the tool design takes a long time, so it's not fully shown here, for sure. But to have a feeling how it's working. What we see now is the directly integration of the predefined cutting punches, for example. The fully redesign, and when we're looking forward to the result, also the fully mounting of the punch in that area, with the 3 spaces. Also, when you see that the area for the waste directly throughout the plates in the bottom part are fully integrated and can be fully predefined by using your standards from your side directly inside the system. Next step is to showing the standard components. We have a huge database integrated in the system for standard components coming directly from the customer, from the areas here. For example, for Moisburger setup or any other suppliers you want to have, can be fully integrated with the part itself and all the machining areas also. So finally, we're going to the die debugger section to check if we have any interferences in the part itself. Do we have any mismatches? Do we have built any faults inside the material that we're going to crash into the first physical tryout to check if something happens? Do we have any functionality errors of the tool itself, and also to visualize the general movement of the tool itself? And now we go to the area interference, for example, interference check, and you see, okay, there's something happening, and you can directly show, let the system show where it's going to happen. So we have here an error in between of the stripper height. So this.
Thank you for taking the time to explore what LogoPress has to offer. From intelligent strip layout tools to powerful flattening capabilities to complete die design environment, LogoPress gives engineers everything they need to design faster, work smarter, and deliver tooling with greater confidence. Whether you're optimizing early-stage concepts or validating complex progressive dies, LogoPress streamlines every step of the workflow, helping teams reduce rework, shorten lead times, and improve overall manufacturing quality. If you're ready to modernize your process and give your engineering team a more efficient, predictable, and reliable way to design tools, LogoPress is here to support you every step of the way. Thank you.
So when we can go back a little bit more into the video, where is the synergy between LogoPress and STAMPACK itself? We have designed a complete strip layout, we have designed the complete bending parts, more or less the holding plates, anything what happens with the manufacturing of the part itself. And that's the area when we switch over the geometries before we continue with the tool design itself to check if the idea, what we have here, in a correct way. So when we continue, we show the next step to the virtual press, to the values of simulation. Yeah, as we've seen, we have two kind of simulation solvers integrated in the software. That means for each type of part you want to simulate, you will have different requirements towards the simulation itself. So in that case, we have two solvers integration in our software, the so-called shell simulation, so the simulation on the flat-based, and the solid simulation. The shell simulation is done for the classical automotive part. For thin sheets, that means 1 millimeters, not more in thickness, with larger radii. Yeah. For thick sheets with small radii, that means that the bending radius or the forming radius is smaller than the sheet thickness itself. It gives you the suiting meaningful first impression, but not the detailed result you want to have. The shell results has a very fast short calculation time and gives you a very fast and efficiency result on one hand. For the other parts, especially for the connector areas or every part that have compression zones inside or the mismatch between thickness and the smallest radii, you have to switch over to the solid simulation. Because the solid simulation is a much more detailed simulation in that case. Stresses and strains along thickness are also considered. You have a very high resolutions towards the measurement, and on the other hand, then also measure maximal precision. It's very important to use it in case of thin sheets and small radius. So when you have massive deformation in local areas, and you have the possibility to detect surface defects in a very, very high detail. What are the classical approaches? The first approach, of course, is the feasibility itself, to see if we have any issues, cracks, situations, what is the behavior inside the material? Is the crack only more or less something that's on the skin of the part? Is it going inside the part? Do we have a full crack of the area in a deep drawing part, for example? But the very important thing, or much more interesting, is not only does it have a crack or not. The much more important thing is how far away I am from a failure. Is it a more or less running along the edge situation? Yeah, that you are nearby a fail or not? Or are we far away? Because this has two interesting features. The first is when we are here nearby the 100% marker, that means we're going into the fail. We have 0.7% left in our feasibility. So that means any changes in the tool, any changes in the material, and we are running towards the crack. On the other hand, when we have 20% left, we can think about and rethink our design. Okay, what's going to happen when we only took 3 stages at least, and we planned only with 4? Does it have any effect? Can we go more risk towards our tool design? Because we know now that we are simply in good conditions. So we maybe have also a big advantage towards the competitors that want to have this tool. Yeah. So also in the pre-ordering of the system, in the first area, in the first visit, you can say, okay, we at least planned with 5, but the simulation shows are with 4 is also okay. And it gives you a big advantage also in the design. Then classical approach for the automotive is the detection of the wrinkling. As also Sunny said before, very big task in the topic, yeah, where we have problems where we have to decide if it's good enough or no. Where are they? What can we do to intervene in that area? Force. Everything what happens with force inside a tool. It could be the blank holder force, it could be the press force itself, it could be the complete cutting force you need, can be directly simulated virtually to give an idea for which tool in the part we need what kind of force for the hold down of the material, for the lifting of the material. Independently, you will get the full information inside of the software. And when we ask somebody about what he's thinking about simulation, what does it show? Then more or less always the guys have to in mind to the feasibility situation, a crack detection. But more or less, the much more interesting thing is how good is the quality of the part itself? Are we in tolerance? Of course, we have a feasibility part. It's quite good, yeah. but is it a tolerance, yes or no? That's the big question, because this is more or less the final decision of our customer, that they say, okay, your part is good or your part is not good at all. Yeah. And you have possibilities to detect the tolerance check, yeah, to compare the simulation results toward the nominal part that we want to have and see, okay, in which areas we are out of tolerance, we are in tolerance, to directly go back to the tool design or go back to the strip layout, do the first iterations virtually to recheck and get a better quality result in the first tryout later on. Then the springback and the springback compensation. So what is integrated in the software? You have the possibility to calculate the springback itself. But on the other hand, the software gives you the idea how to compensate your tools to get in a good position towards the tolerance. So it will be fully automated. Redesign your tools, run another simulation, recheck if it's better or not, run another simulation, recheck once again until we go into the line. We say, okay, we are fully in tolerance, and then we take out these tools for the first tryout then in the physical world. A very interesting feature is also the possibility of decoining, because it's very related to the simulation of a solid solver, because some kind of coinings you can always run only with the solid simulation. It's impossible to run such kind of simulation areas with the classical shell simulation solver. And that's also the reason why we have both options inside our system, that you have the idea to decide, okay, I have a part that's classical shell based, I have a part that's have to be calculated in the solid solver, but the customer can very easily decide and switch inside the software. Trimline optimization is one of the biggest things that we have in the software, because trimline optimization is something that is fully made in the physical tryout. When you do the first loops inside your tool, you will use any predefined strip design to check whether my predefined blank is good or not. In the simulation task, you can directly see, okay, what's going to happen. And you can say to the system, please redefine my initial blank outline to fit the part the most. So for example, here, we're starting with the first simulation where we have an initial simulation with a deviation of 2.5 millimeters towards the final outline we want to have. And the system then regenerates the blank cutting automatically, fully automatically for you to get more and closer to the target. And he iterates as long as you want it to fit much more the target. And then once again, you will get back this outline from the simulation back towards LogoPress and redesign the strip layout in a very common way. Finally, we have the possibility to have a robustness analysis inside the software to get a feeling which parameters in our system are the most important. Are it the material characteristics? Is it the blank itself? Yeah, you can play around with the software and see, okay, a variation of the thickness in the coil is a problem for us. A variation in the tensile strength could be, in a long-term way, a problem for us. When the yield tensile strength is variation, our target or our tolerance is going out of the normal state. To get a feeling what is more or less the most important parameter inside our process, to get a feeling what is important, what we have to check and secure that it's not varying. Finally, very easy, but very common is the educational possibility. Yeah, you can play with the process inside the software. In the physical tryout, you have to manufacture, then you see what's happened. You have to remanufacture, you see what happened. In the virtual tryout, you can play around a little bit more. Increase the blank holder for, see what's going to happen. Lower the blank holder, directly see. And then you get a feeling for the process itself. When you have a look on this area on top here, you have also the possibility to look inside the tool. And when you close in the physical press, you close the press and then you see the result. But it's very, very difficult to look inside. In the simulation, you have the possibility with cutting sections, as in a CAD system, to see where are the first impact of the bending parts. Yeah, does the material rose as I want to have it, or is it anything happens that I don't seen before? And then we have to say, okay, that we can't do that. We have to redesign the area in that area to get a better result itself. And that's something what you can only do in the virtual simulation. I want to go with you to now one time inside the software to get a feeling what is the usage of the software, to see what you have to do to set up a simulation very quickly, because we say it's made from tool designers for tool designer. So it's very easy to handling. We recommend at least 3 days of training, 3.5 days of training to get inside the software, because it's very easy to learn, because the structure of the software is always the same. Independently, if we do an automotive part, connector area, embossed sheets, it's always the same approach in the software. And I want to show you it on one stage that we have a feeling how fast it goes to set up a simulation in our software. So this is the interface, what you see now. We have here on top more or less some kind of timeline. You're playing around from the first step to the last steps to the results. Left is your work area. So for the first, we go to the next step, and the system wants to have a name for the project. So we have to save it. Next step, blank definition. So the first, what you want is, the system wants from you is the thickness. In our case, 3 millimeters. Then we have here the decision of the shell and the solid simulation. And you can always switch this area as you want. You can start with shell, switch back later to solid, or backwards if you want. You don't have to redesign the complete simulation itself. Only click on this button and rerun the simulation. That's quite easy, and this makes the possibility also to more or less play the ball to each other to see, okay, what's happening in the solid, what's happening in the shell, to get a feeling for that. Material database, very important. We have a huge database included. Over 600 materials are directly implemented in the software coming from scratch. So they have also a huge portfolio. When we looking for any material, any great material. So it's also in the US, in the EU, and also in the Asian market. We have different areas. What's for the naming of the parts. So I think it's for everybody something inside. But nevertheless, I take once and go to the next step, implementation of the outline. And that's what's coming from LogoPress. So what you need to define the process is, for the first, the outline of the predefined blank. One is the flattened area of the system. So this one. 2D, IGES file. And the next step is the system wants to have from you the information of the smallest bending radius inside the whole process, inside the part, for example. You type in this, and the system directly suggests you the parameters for the meshing of the part, because it's a full mesh-based structure. So FEM solver's working with the mesh, but it's very easy. Sometimes it's very difficult to decide how coarse or how fine the mesh in which areas has been. So the system will take over these meshes from you and fully integrated it automatically. When you switch to the solid simulation, once again, create blank, and you will get the blank in a solid structure. Fully automaticated from the system. Then you have different situations here. You can add symmetries if you have. You can add the strip conditions if you're working in a progressive tool, for example, tool design. Independently, you can switch it on, switch it off if you need. We go to the next step, process design. In the process design, they're integrated the trim optimization, for example, and for ARM, they're integrated the classical operations menu. So you're starting with the first operation, add the second, the third, and so on and so on. So you completely design your layout inside the software. What you need for that is simply to import the defined tools coming from LogoPress, for example. In that case, 2 tools, upper and lower part of the part. So for the first stage, flattened based, fully integrated. You can add it as classical step parts, as predefined STL meshes. So we are completely neutral in the inside of the approaches. Also NX Parasolid, and of course, classical neutral areas are possible in that area. And the only thing you have to do now is to simply drag and drop the tool inside the area where it is in your physical tool. We have a press RAM area, we have a press table area. Simply drag and drop. That's a punch in the top and time, and it will be directly inside. Simply drag and drop, lower part, and that's all. Now the kinematics of the tool are full ready. The system is loaded in a closed condition. So the system knows, okay, that's the closest point, the deepest point of the tool. We have to simple open the tool and close it once again in the simulation. That's what the system is doing, more or less. Now the system is fully prepared for the first step. We go to this next office and let the simulation run. In that case, I have 24 cores of the CPU. Click on play, and the simulation is running. And that's more or less all. Yeah. Now the system is running, so the complete geometry is overgiven to the calculation solver. That's what we've seen here in this output information. Now it's starting. I will run it just to have a feeling and to show you what's going to happen now. He first writes some results, and you see now, okay, we need at least 30 millimeters of stroke that will be directly calculated. And now he's starting. He's closing step by step the press. We can go directly to the result area and see what is the result actually. So what's going to happen now? He's starting to close, and we see one functionality we have here. He's starting to redefine the mesh in the local areas. And that means the system has an automatically features to detect where the system is closing with a smaller radius than the tool the mesh size we have here, to see, okay, we need at least to redefine the mesh structure in this area to get a better result. And this makes this simulation and also the calculation time as powerful. Now you see what's happening. He's redefining this area directly. And this gives a huge impact to the calculation power we have, so that also a volume solver like that is ready within 1 or 2 minutes with the result of one stage. And that's not quite common. In that area, we are the only system in the market that has this functionality, this fully automatically functionality in the volume solver. And at least this gives us the power compared to the other volume solvers to be 5 until 8 times faster in the calculation time to competitive simulation softwares. Of course, inside this area, we can look onto the actual status of the results. We can look for safety zones. We can look for thinnings and so on. But of course, I don't want to show you all the features because we have much more features inside. I want to go back now to the software, to the slideshow itself to give you further information about the process. So what is now the synergy between the tool design and the simulation loop? As I said before, we have on one side the local press error with the flattening, the strip layout for the first ID. Then we go first time to the press and the validation simulation. We iterate with the strip layout. We update it inside the CAD system, very quick and easy. We iterate the simulation once again. We get the information of the springback. We get the information of the compensation of the springback, trimline optimization, and so on, until we define the perfect strip layout where we say, okay, now that's the perfect match. That's the strip design we want to go to the physical tryout later on. And then we continue with the die design, with the die debugger, and of course, later on with the manufacturing. When you compare this now with the conversive loop until virtual loop of LogoPress, and the conversive loop, you have to redesign the material. You have to redesign the tool itself. Yeah, we have to check what we want to do because we have no idea what happens. We only see the result. We have first to check what happens. In the simulation, on the other hand, you directly see where it happens, why it happens, and you have the first idea what to do. You know the process much more better because you can look inside the process. And this leads to a big difference. Time, cost saving, of course. Stress for the employees. It's a big topic. Yeah? They have stress. They have to decide quickly what to do. And when you have to decide very quickly under pressure, you make faults directly. You have an idea what to do and something happens, but it was not that what you want to have. You are not in the target. So once again, we iterate once again. And in the virtual loop, we have much more time because you are in an earlier stage of the development. You are much more effective in this area. And finally, of course, let's go to the bottom line. Yeah, we're always talking about costs. We are about talking about be faster, be smarter, yeah, and so on. But what does it mean exactly? When you have a look on this, what are the potential benefits of those tryouts? Of course, we are talking about reducing tryouts costs by far because you're getting better. But we are also talking about process simplification. As I said before, when you know how far away you're from a failure, you can go more risk. Yeah, maybe you can redefine from 3 stages or 4 stages to only 3 stages. Another big impact is you can also maximizing your material efficiency, because you don't have to add more material to be secured. You know how many material you know, and you can reduce it by millimeters. Maybe you can reduce also the strip feed by millimeters, because you know directly how much material is needed, because you've seen it in the simulation. That brings you in one tool a little effect. But when you think global towards your complete company, how many tools do you in a year? Then it's a really big impact. I have also some numbers for you later on to see that directly. And of course, it also gives you facing directly in the modification costs, in the redesign, because as I mentioned before, you know what to do. You don't have to think about, okay, we have now a problem in the physical tryout. Let's try this. No, that wasn't it. Let's try this. No, it wasn't also not. Yeah. So to directly see in the virtual tryout what makes sense to implement and what does not make any sense to implement. So we have a feeling about the happening, what happens with your part. These are fully measurable benefits that you have directly. But there are some other benefits you have. There are some kind of strategic benefits you have with some kind of software. Of course, when you reduce the loop up time, when you reduce the time you need on the press shop floor to do the physical tryout, you're directly unlocking machine capacity for the presses, but also for milling machines, for any machines you need to manufacture a tool. You will directly unlocking this capacity, because former it was planned for the tryout phase. Now you don't. You reduce this tryout phase, then of course you don't need as much time here. Another thing is, when you're using simulation software, you can use it also strategically in the talking to your customers. Yeah, it increases the trust towards the customers when you see, okay, they think what they do, they see what they do, they have a smart way, they are very digitalized in this area. We can trust them. That what they do, what they work, is perfectly fitting to our strategic view of a company. Then, of course, you're reducing generally the general time to market, coming from the first planning of the tool until the first ramp up of the tool. Yeah, this time will be completely compressed in this area. And once again, this directly relating to the unlocking of the machine capacity. And on the final hand, as I said before, in the physical tryout, several persons are integrated step by step. In the virtual tryout, more or less only the designer areas are integrated. So in that case, we have to check what's happening, and you directly employ the capacity gains directly to get more capacity out of your employees itself. And when we think about the costing itself, you can classify these potential areas directly. On one side, only the tool shop, but when you think more global, also towards the press shop. And in a whole company, we have a tool shop and a press shop, and more or less there are some synergies in the costing, because the costing are fully made in the tool shop. Of course, you have to completely design the tool and you bring it out to the press shop. But the effects are more or less have some kind of synergies to each other. When we say what happens in the tool shop, we have savings to the reduction of correction loop itself. Of course, we have savings through the optimizations in the tryout itself, because we are learning the process behavior. We know what's happening in the process. And of course, we have savings through reduced tool lengths and complexities, because maybe we have a bit better approach towards the part. We don't have to make it as complicated, because we've seen in the simulation that it's working. On the other hand, we have the press shop area. We have savings through the higher material utilization, as seen before. We have savings to the reduction of unplanned press line downtime, because we have to recheck, we have any issues. Yeah. We have savings through the lower scrap rates in the production. Of course, we know what's happening. We have a stable process. Yeah. And we have savings through the reduction of rework during the ramp up phase. So when you stay a startup phase, when you have a full, more or less, when you have to bring the material towards our customers. And to categorize these 7 areas, you can directly bring this also into numbers. And I have a very interesting example for you. When we have an example from a medium-sized tool shop, for example, coming from the connector market, doing connectors, plug components, with more or less approximately 15 new dies a year. Yeah, We have no external procurement, no production from an external supplier, and our production volume is around about 100 million parts per year. Just an example. Then you can have a look to these 7 impacts. What's in money? Yeah, you can clarify this. And by far, this is a definitely conservative calculation. Yeah, we have in every area we have some kind of conservative roundabouts. Yeah, not detailed numbers, but conservative numbers. I think that the real impact is much higher than the numbers we see here. And you see in the tool making we save at least $340, $1,000 a year. Yeah, only by using tool length recoverability and of course reducing the quality loops. That's the big factor in that area. On the other side, the number is not as high, but the number is there. Yeah, 2 saving of material, 30,000. 2 savings in the crash rate assessment, 15,000. So also there's a huge impact when using simulation, and that's the big measures we want to show you today, to think about, to rethink your process chain in general, to say, okay, let's set in a tryout via simulation in between our general design to make our process better, to make our impact towards the reality better, and to save time and money at least. So that's all from my side for the day. So looking forward to your questions later on. So I will hand now to Anna to bring you to the further presentation itself. Thanks a lot from my side.
Thank you so much, Sebastian. Yeah, it's a great presentation, by the way. Congratulations. Okay, so maybe nasabi na ni Sebastian yung mga connections, no, between dun sa market, no, pag-develop ng DAI, no, nasabi niya na yung how important for us to lessen the tryouts, no, and then yung try and error process natin, no. So but to relate it in more sa Philippine industry, no, or sa ating tulad DAI manufacturing sa Philippines, no. So ano bang ibig sabihin natin sa atin ito pagka mas na-lessen natin yung tryouts and also yung trial and error, yung mga pack import sa machine shops, no, repeated tryouts sa machine shops natin and also sa press natin. So it means, no, pag nabawasan natin to, imagine the improved yung development natin is na-shorten natin, no, yung process, na-reduce natin yung mga errors natin in the tryouts process, no. Of course, kapag nagawa natin yon, we can accommodate more jobs, no, sa ating tool shops, no. We can accommodate, we can add more machines, no, if we're growing, no, we're getting faster to build our tool and dies, no. So hindi lang sa pag-less ng cost ng manufacturing na-improve natin kapag meron tayong simulations, no. Because as Sebastian mentions, no, you can play along with the simulations and the die simulations within your company, no, to learn what is the effect of this punch and die or this kind of forming in your side, no, para mas ma-optimize natin yung ating mga development, no, na process sa manufacturing natin. Of course, kung we are reliable, no, tool and die shops, no, a customer will find us the first option, no, para sa kanila for the new jobs, no, because we can deliver faster and we can be more efficient and effective dun sa cost ng ating mga ginagawang tool shop. So yeah, I think that's it, no. That is how you connect our solutions, no, with these industry standards dito sa ating Philippines, no. Actually, halos parehas lang naman yung nangyayari, no, between the Philippines and the other companies, no. Nagkataon lang, no, na mas develop na sila and they are more reliable sa mga solutions like this, no. Nauna na silang gumamit because sa Philippines medyo nahihirapan tayo, nag-hesitant tayo to use the solutions for us, no. Inisip natin lagi yung ROI, no, hindi pa natin nasusubukan. We are thinking about the ROI already, no. But if you can rethink, no, reevaluate the value of these solutions, no, maybe I can try it over and then see the results from yourselves, no, kung ano ba talaga yung impact nito sa ating company or sa ating market. Ayan.
Yes, Tito.
Okay.
Tama ka talaga dyan, Tito.
Yep.
Yes, actually, we've spoken also, Sunny, with some of our customers na nasa metal industry. And they have been talking about how, let's say, Vietnam and Indonesia has been improving on yung scale ng kanilang manufacturing hub. And 'di ba? Parang the question is how about Philippines? So the owners no, sabi nga nung mga ibang owners sa atin, yung ating mga clients is we don't necessarily need to compete with them in terms of what they can do in the factory kasi maaaring mas malaki talaga yung mga factories nila, Tito. And the volume they get is a bit higher, especially now that Indonesia has uh, taken a big leap with yung kanilang nickel, ano, 'di ba? Nickel initiative that is supported by the government. So ang sabi nga ng mga owners, we don't really need to increase yung ating factory, palakihin yung mga ating factory, but how we can be competitive is to be efficient and to improve on yung ating product output. And that's why itong ang STAMPACK and logo press also came into picture. 'Diba? So hindi man tayo makalaban dun sa laki ng factory, makakalaban tayo in terms of how fast we can do our dies and the quality, 'di ba? Syempre at the same time eliminating itong mga trial and error cost. Yun lang, Tito, nakisali lang ako sa conversation. Opo.
Actually, it's
Yes.
a good point po talaga. Yes.
Yes, but yeah, again, thank you also, syempre, na sa ating speaker today, Stefano. Appreciate your. So 8 o'clock. So I'm assuming it's around 10-ish now in the morning.
9 o'clock, it's okay.
9 o'clock is still okay. So
No,
it's
it's no
still,
problem at all. It's quite normal.
it's still not time for some cold Kolsch beer.
No, not yet.
Not yet. Yeah. So Anna, I give you the floor. But I think we have some questions from our audience.
All right. All right. Thank you so much, Sebastian, Miss D, and Sir Sunny for the collaborative and interactive presentation for that. So let me share my screen. So before we proceed to the Q&A, please answer these feedback form for us to have time to answer this feedback form. Can just scan the QR code and Miss Pawi will nasend na pala. Will give the link of the feedback form in the chat box. So if you have questions, please type in your questions in the chat box. So are there any questions? I have already one question that nag-send kay Miss D through text. So I don't know if Sir Sunny or Sir Sebastian can answer this. Can progressive die stages be simulated individually and as a full strip process? So, nakatagalog kasi siya eh, so I don't know. Sebastian?
Yeah, for sure.
Okay.
So it's depending, yeah. So as you can simulate both approaches, no problem at all. But in the most cases, we simulate more or less one stage after another because there are throughout the setups in the simulation itself. It's not necessary to simulate the whole strip design itself, but it's not problem at all. It's depending on the defining you want to simulate. It's possibly, yeah, but you have to think about the bigger the strip, the longer the calculation time. To be more efficient, you receive it to watch each step, yeah. But important to know, we are simulation a progressive die. So that means when you have the first result of the first stage, the results will be directly overgiven to the second stage. They are not isolated from each other. So it's fully made.
Yeah, thank you for that.
Thank
That's
you.
a good point.
Are there any questions? Other questions? Pero, wala na. Wala na. Okay. Just, meron po bang questions or clarifications regarding logo press or STAMPACK? Kayo, Sir Sunny, baka you have question to Sebastian.
Not on my side, Anna.
Ayan, I think Miss D have a question. Can I validate forming force and press tonnage requirements?
Yep, absolutely. Yeah, quite easy to answer. It's fully implemented in the system. Maybe when we have a few more seconds, I will once again share my screen and show it you directly how it's gonna happen. Maybe mark with some kind of placative.
Is this under the express package as well?
Yes.
Okay, yeah.
So when you see my screen once again, you think yes,
Oh,
it's
sorry,
open.
sorry.
Hold on.
I will
It's
stop share first.
Yeah.
So
The question is from Miss Joy.
Oh.
Now we're back again. Yes. When we go back to the simulation we made together in between, you have the possibility for each tool in the process. So when we go to the operation, you see directly what tonnage is needed, for example. For that case, we have here 3 millimeters wide sheet. Yeah, so we need at least 260 tons to precise this part, for example. And of course, when you have another simulation, let's have opened another one. That's more or less the full process of this part. And we go to the, let me see, I think to the bending area. That's quite interesting. Just once more here. We have also integrated a blank holder, for example. Yeah. And you have also the possibility to see the needed blank holder force. So it's increasing until to 125 tons. Then you say, okay, it's completely closed in that area. So you can have the option to set in the correct force that you have to see what happens with the force. Or you have the other approach, I don't know what kind of force I need. Then you can also say to the system, please tell me what force is needed. So both approaches is possible in that case. I think this will answer your questions. If not, of course, give feedback.
Yeah. The customer said yes.
Okay.
Yeah.
Okay.
Also, Sebastian,
okay.
this tonnage calculations also can be done in logo press, right?
Yep. Exactly.
Okay. I have one question from another customer, from an attendee also, through text also. Are we able to simulate the current stamping configurations of our machines into this system?
Not in detail. The thing what you can integrate is more or less the possible tonnage. If you have a press standing there with maximum 600 tons, for example, yeah, then you can implement the system. Okay, I have only 600 tons. I have to produce this part. What's gonna happen? And it could be that the system says, yeah, we at least 0 to 2 millimeters before close down the complete, we have to stop because we are reaching our limit, for example. And this leads to a different springback condition that leads to a different behavior in the part itself. That could be possible. But what we not do is more or less to integrate how fast you are driving to the part, or if you have some depending on the kind of press you have, some different speed up of the part itself. It's not integrated actually.
Okay. May another question.
Yeah, sure. You're fine.
So I think the attendees are a little bit shy. So how long does a typical simulation take?
Yeah, it's quite difficult to say because it's depending on the part itself and on the stages you want to simulate. The more stages you simulate, the more it takes. When we go back to the system we have driven before, it takes at least I think 3 minutes was the time we have for the first stage in that case. But we have also simulation that takes 10 minutes, 20 minutes, at least also 10 hours. It's also possible. That's depending on the part itself and then it's depending on the approach. Our goal from our system itself is that the simulation have to be done overnight, maximum. Because the idea is that the customer say, okay, I doing my design also with the options we have, with the fast calculation modes we have during the day. And when I leave my office in the evening, for example, I play on the button for the finalized visualization, and this runs overnight. I have to take care about that. It's running. And then I come back the next day in the office, I see my results. And that's the goal we have, because then we have no impact and the machine is more or less like a milling machine, fully evaluated over the whole day. That's the idea.
Actually, that's why STAMPACK has shell and solid options within the simulation. If you will try to actually to study first the simulation, you can use shell to pass to make it faster, and then after a while, once you are convinced what on how the material would you like to simulate, you can use the solid and then run it overnight, something like that, right, Sebastian?
Exactly.
Okay. Is there any more question, Miss Anne?
For me, there's no text anymore, I guess. Oh, Sir Paulo Realubit ask, do you have any idea what type of material or steel sheet is being used in the deep drawing process?
Yeah, more or less it's depending on the customer's decision. Yeah, what kind of pipe you have to develop. Yeah, but what I can say from our side, you have more or less a huge portfolio of deep drawing materials inside. That's the point. Yeah, so you can see, okay, what is the technical proposals of each material? You can combine them and see to the material characteristic which kind of steel is more or less better useful for the deep drawing and which kind not. Yeah, but it's also a task from our training that the guy is talking about the material itself to show you, okay, what are the important characteristics, what are the more or less not so important characteristics, to get a feeling for that. But more or less, due to the huge database you have in that area, you have more or less the full strength of that.
Yeah, he also, Sir Romel from Yamaha also has two questions for you. Number one, how does STAMPACK handle fluid pressure simulation in hydroforming compared to the traditional deep drawing? That's the first question.
Yeah, the first question we can answer quite quickly. We have not integrated hydroforming actually.
Okay. The second question is, how would STAMPACK handle multi-chamber hydroforming profiles? But as you mentioned, there's still no hydroforming, so I'm assuming there's no multi-chamber for this one yet.
Exactly.
And also, no, I want to add to answer Sir Paulo questions. No, actually, he wants to decide what is the best materials to use. No, so that's why having a simulation on your company can help you decide which material is best for you to use in deep drawing. No, you can play around with the materials there at the library. No, so pwede mo nang sabihin, sir, kung tatanggapin mo ba yung trabaho o hindi, kasi doable naman siya based on the requirements ni customer, no? For example, there is a material there na hindi kayo masyadong familiar and that material is included in the library. No, you can play along with the simulations to actually verify if it's you're going to take the job or not, something like that. Okay, ayun po. I hope I answer it. Yeah. Is there any more question in our attendees? Okay.
Are there any questions? Please continue to fill up the feedback
Our feedback
forms.
form.
If you're still thinking about any questions for Mr. Sunny and Mr. Sebastian, are there? Oh, sir. Thank you lang pala si Sir Paolo. Oh, if wala na po tayong questions, if meron pa naman tayong questions, you can still text us or email us. So we
Sa,
can,
sa akin,
ano,
Ana, may nagtanong eh.
ano yun, ma'am?
Nasaan daw si Miss Elaine?
Actually, we are currently in a trade show po. So, two events in 1 week. So, ayun, very
Right,
busy
yeah.
ang CSI.
Yes,
Kaya, ayun.
tama.
Si Sir Sunny nasa Subic siya ngayon. Kasama
Yes.
sila.
So,
Yes.
so actually only 20% of CADCentric is naiwan dito sa Halabang, including
Yes.
myself, and 80% like Tito Sunny are in Subic. So they are supporting naman our brothers and sisters sa Philippine furniture and wood. Diba? Yung ating mga ano doon, customers natin sa Subic at sa Pampanga. Yan. So may
Yes.
trade show. So kung sakali na magagawi po kayo doon kasi weekend na sa Subic, maaari niyo po silang makita sa Subic Convention Center.
Yes
Booth
po.
A1010.
Yes.
Nag-plug fail.
That's correct.
Oh, nagulat
Yun
ako,
po.
chinat ako, sabi, asan daw si Miss Elaine?
Usually kasi Miss Elaine ang kasama ko dito sa webinar.
Oo.
Nagulat siguro sila, si Miss Pawi ang kasama ko.
Yes, oo.
So, ayun.
Ayun. So, I think, Ana, may mga nakapag-submit na ba ng feedback form?
May mga nakapag-submit na pero 4 pa lang, ma'am.
Mm.
So, ayun, please fill up the feedback form so we can, see your insights regarding
Our webinar.
Yep.
also the software itself. So, para our coming
Mm-mm.
feedback regarding that. So, let us proceed na po
Mm-mm.
for the sabi. So, yun, maybe let's take a picture for documentation purposes. May I request everyone to open their cameras and have a picture with us? So, I'm stop sharing. Ayun, ang dami talagang yung VPMI, yung Valerie
Yes.
products,
Oo.
tama po ba?
Yes.
Ayan, nakakatuwa kasi ang
Valerie
dami
Group,
nila.
talagang magagamit nila tong logo press at STAMPAK.
Ay, tatagalin ko muna yung, ayan. So, Sir Randy, magpakita ka naman, Sir Randy. Nami-miss ko na yung, nyo, curly hair. Ay, anong Sir? Bayan naman. Paano na yan, Sir? Hindi tayo makakapag-picture together. Ayan, smile po tayong lahat.
Yeah.
Ayan. Hi, Sir Claude.
KPC.
QA po. I think yan po yung KPC po. Under kila Sir Roland, Ma'am.
Okay. Syempre talagang si Ma'am Joy, hindi talaga nawawala talaga to si Ma'am
Siyempre,
Joy.
Ma'am Joy from Ramcar. Yes.
Yes, oo.
Kala mo, ma'am, di ka namin tatatanan dyan, ha? Ayan. So, ano na si ma'am from Yamaha. Naka-peace sign na siya, oh. Kitang-kita kita, ma'am. Sir
Opo, sir.
Sunny, cute ka daw, sabi ni Sir Randy.
Oo.
Ayan, mag-picture na tayo, no? So, 1, 2, 3. Ayan, with peace sign naman, with peace sign.
Peace sign talaga.
Oo. Ay, heart na lang, heart na lang. Okay. 1, 2, 3. Ayan. So, thank you so
Thank you so much,
much.
everyone.
Thank you so much, everyone. So, let's, I'm a screen share again. So, ayan. Next tayo. Alright. The most awaited part of this program, ang ating icebreaker. So, there will be 5 winners who will have a chance to win 300 pesos via GCash. So, if nanalo na po, di na po pwedeng manalo sa next round, next question. So, we should give chance to others. So, for the mechanics of the game, the first to comment on the chat box, the correct answer wins. So, after I say go po G-O, go, doon na po kayo mag-start, mag-comment, or i-type in yung correct answer. So, please type understood kapag naintindihan nyo po. Naintindihan po ba? Understood. Yun.
So, Ana, di ba, pag nagsumagot sila before mo sabihin yung go, hindi kasama yung ano nila, entry.
Yes,
Ah,
exactly. Kasi sa mga other webinars po namin, hindi pa ako nag-go, sumagot na sila. So,
actually, hindi ka pa nga
ayun.
nagtanong, may sagot na sila.
O, yun
Ganon,
nga
oo,
eh.
ganun kagaling yung mga customers natin.
Hindi ko alam kung
Ano.
nalilik ba yung presentation ko eh.
Tingin ko may nagli-leak sa atin.
Yun na nga eh. Sir Sunny, ikaw ba nagli-leak? So, hindi ko alam.
Ayan.
Intuition.
Oo.
Friendship.
Yun na
Ayan.
nga eh.
Already na daw sila,
Ay,
friendship.
meron pa akong mechanic. So, dun sa question number 1, 2, and 4, meron siya maraming choices. So, but only one answer lang naman yung sagot. Ganon. So, yun na naman. So, isa pa rin naman yung isasagot nyo. So, many choices pero one answer lang naman. So, let's go. Are you ready? Okay, go. So, first question. What is logo press used for? Wala pa akong go ha. 1, 2, 3, go!
Okay, so meron na tayong ilan ang nakakasagot?
Ayan.
Ayan.
Okay, meron na tayong winner. Next na tayo. Next slide. Si Sir
Kernan.
Kerner. Si Sir Kernan
Kernan
Gumapak from Shimano. Progressive die design. So, ang logo press po kasi, it's more on designing po siya. So, more on creating, strip layouts, ganun, kineme roots. So, it's more on, hindi po siya sa simulation. Kasi po, ang simulation is, di ko na po sasabihin yun. Kasi, baka, char, okay. Basta, ang logo press is more on design.
Progressive
Diba?
die design. Yes.
Yes. Basta sinabi ko yung kanina, di ba? Progressive is for design. STAMPACK is for... Di ko na sabihin yun. So, ang nanalo po, sino? Sir Joshua? Ano sabi mo na? Okay. Sabi ko na, si Sir Kernan
Gumapak of
from
Shimano.
Shimano. Congratulations, sir. Okay, for the next question. Number 2. Many choices again to, pero one answer only. Give one example of die design challenges. 1, 2, 3, go! Ano nga ba yung sagot dyan? Kalimutan ko. Ayan, okay, may sagot na.
Yes.
Okay. Okay. Ayan, nadali mo. Ay, sorry.
Yes.
Wala
Tama,
pala.
nadali mo,
Wala.
sir. Sino ating winner? Friendship?
Si Sir Romel Don.
Filiado
Filiado from Yamaha.
Yamaha Motors.
Yamaha Motor. Okay, congratulations, Sir Romel. So springback and dimensional accuracy, complex trim lines, can connect, emerald. Okay. Number 3. Ito. Ito na yung pinaka-iniintay nyo. Ito, main part to ng webinar. Okay, ready na kayo? What is STAMPACK? Ayan na. 1, 2, 3, go! Sumagot na si Sir Shimon. Oo. Ay, ko. Narinig pala ako. Ayan. So, STAMPACK is specialized sheet metal forming simulation software. Ay. So, si Sir... Asan na? Wala ako.
Ayan. So, we'll be considering yung sagot ni Sir Stefano Barros. Sir Stefano, hello. So, yan. Kasi ikaw yung may ikaw yung nauna and then malapit dun sa answer for the number 3
Yes.
question. So, stamping simulation for sheet metal.
Congratulations,
Congratulations
Sir
po.
Stefano.
Yeah, so si Sir Stefano is from COA.
Ah,
Yan,
okay.
COA
Ay, oo
Yeah.
nga, Sir Stefano,
Mm-mm.
napunta yan ng mga events natin.
Yes.
Yeah, I remember. Okay, next question. Next question, many choices, but one answer. Okay? Are you ready, guys? 1, 2, 3. Go. Go! Give one example of a defect that STAMPACK can analyze. Go! Nakasagot na ba, Sir Paulo? Ay, hindi pa. Ayan. Tama. Okay. Bilis naman ni Sir. Sure ka? Ha? Hindi nga na. Ay, wala pa siya. Okay. Okay, may nanalo na. May nanalo na. Char. Ayan, may nanalo na nga. Sir Paulo.
Sabihin mo, sige.
Ayan.
Yes.
Si Sir Paulo.
Rialubit. Ayan. So, crack or cracking
Crack.
ang kanyang sagot.
Crackling, wrinkling, tearing, thinning, springback. Yeah, crackling na chichirya. Char. Yes. Ayan. So, marami kasing defect
yes.
ang na-analyze ng STAMPACK.
STAMPACK. So, congratulations, Sir Paulo.
'Di ba?
Okay.
Kung meron kayo STAMPACK, o 'di ba, ma-analyze agad 'yan kapag char. Ayoko naman. Ano pa yun, no? Demo pa. So, next. Last na to, ha, guys. Etong cracked. Yeah, I'm cracked. Char. So, sa 5, si Sir Sunny ang magde-decide. Sir Sunny, are you here?
Bakit ako?
Kasi ikaw nagsabi nito sa akin. So, si Sir
Ganun.
Sunny
Sige.
magde-decide who will be the winner.
Winner.
Yeah. Chat mo na lang sa akin, Sir Sunny, if sino yung winner. Okay? So, for number 5, here is the question. If I said go, doon kayo magsasagot. How logo press and STAMPACK do in your company or production? Go! Ayan. Essay siya actually. Dapat 100 words. Eme. Eme lang mga guys. Baka kasi din na kayo umattend. Ayan.
Can do
Wala-
tayo nata. How
Ha?
logo press and STAMPACK can do in your company
Can do,
or
sorry.
production.
Can do
Yeah.
in your company, or production. Sorry, kinapi-paste ko lang kasi yung sinabi. Hindi na. Ayan, Sir Sunny, may mga sagot na sila eh. Kaso
Yeah.
hindi lang essay. Hindi
Yes.
pasok sa standards mo.
We have to answer. Ayan, 4 answers na Sir Sunny. So ang unang sumagot ay si Sir Harold. So from Sir Harold, Sir, pababa. Yan yung i-check mong sagot, sir.
Okay. Si Sir Harold, ang answer niya is actually correct naman. It's prediction, right, sir? Tama ba yung answer mo?
Ay,
Yeah.
ano, Sir Sunny? Sino ang iyong winner?
Actually, si
Okay,
Sir
so
Maunong, enhance productivity in the metal stamping industry. Yeah. So
okay.
that's
Si Sir Mauno. From Valerie Group.
Congratulations po. Ayan, so ikaw, sir, ang napili ni
Na ano mo na,
Sir
Sir
Sunny.
Joshua. Ayan, congratulations, Sir. Ayan. Ay, tuloy ako. Pumiyok tuloy ako. Ayan. Kasi wala akong talagang answer because anything is correct. Depends on the on the company kasi. So, congratulations to the winners. So, you may contact me for e-certificates and claiming of prizes. So, email Anna at CADCentric or contact 0995-456-360. So, you can screenshot yun na or
Yes.
picturean yun na. So, I'll give you siguro 5 seconds. 1, 2, 3, 4, 5. Ha? So, ayun. Thank you so much and congratulations to the winners.
And
Feedback forms.
yes, please don't forget yung feedback forms natin, guys. So, kanina na-reflect, ayan. So, reflected again on the screen is our QR code. And then, ilagay ko na lang again yung link sa ating chat box. So, but before, we end this webinar, no, we also want to inform you guys that the e-certificates for this webinar, please email Miss Anna. Okay. So next slide. Tapos na ba tayo? Friendship. Ayan. So before we end the webinar, we want to show you our team. So meet the CSI team. Ayan ang aming team. So sales and marketing team, we have, of course, our general manager, Miss Diana Escalambre. Yours truly from sales, along with Miss Luz Basan, Sir Luigi Vivas, and Jeremias Huntilla, and our subscription officer who handles yung ating mga renewals, Miss Elaine Bautista. Our beautiful marketing ladies, ayan, Miss Ana Opeña, and Miss Angeli Del Rosario. Ayan, wala lang si Miss Angeli since nasa event siya sa Subic, no? So there you have it po. That's all for today. Okay, so teka, EQ in. Sorry, we have our CADCentric team applications engineers and our technical support team. So si Sir Sonny Rivera, he's handling the technical team of CADCentric Solutions. So si Claude Santos, our elite applications engineer, ayan. Si Sir
Yes.
Jerome Deang, he's new din sa CADCentric Solutions. He handles SOLIDWORKS, draft site, as well as the technical support as well. And Sir Joshua Gamay, ayan, pakita ka naman, sir. Is with us kasi now. So yan, si Sir Joshua is part of our technical support group. Okay, so i-ano ko muna ha, ilagay ko muna ulit yung link ng ating feedback form.
Yes. Ayaw ni Ma'am Pawi na mag-goodbye sa inyo unless hindi nyo matapos ang feedback form.
Yes po. We'll appreciate po if you could fill up the... By the way, kung hindi nyo siya mascan, we will also send it to you, no? We'll appreciate po if you could fill up yung ating feedback form.
We will send it to you after the webinar also.
Mm-mm.
So,
So, ayan siya,
ayan.
guys.
So,
Thank you so
ayan.
much.
Thank you. There you have it. And that's all for today. Thank you for attending STAMPAK webinar featuring Logo Press. We hope you found the session very informative and engaging. We really appreciate your time and participation. And stay tuned for our upcoming events and webinars. So this has been
Pawi,
and Anna. See you on our next events. Bye!
thank you so much.
So, pag pupunta po kayo sa Subic, punta po kayo sa Subic Convention and Exhibition sa